All right, welcome back. So we are actually moving on to a whole new chapter here. Although the skills that you've learned recently are going to be applied directly to what you're doing right now. So this could have been the same chapter because we are still working with quadratic equations and functions. We're just doing different things with them than we're doing before. What we're actually doing now are solving quadratic equations. So before we get into how to solve them, it's important to understand what we actually mean by solving them. So far, we've been working with equations that have looked like this when they're in standard form. Either y equals ax squared plus bx plus c, or we say f of x equals ax squared plus bx plus c. Remember, they're not always in standard form. They can be in vertex form as well, but we know how to handle them in both ways, so it doesn't really matter. This is kind of the general form that you'll see them in most often, so it's good to kind of start here. When we're solving a quadratic equation, we're actually looking for very specific values of x. We're looking for the values of x that cause y to be 0. So basically, we're solving the equation ax squared plus bx plus c equals 0, and we're trying to find the values of x that make that happen. Now remember, a, b, and c won't be letters when we're actually solving the problem. A, b, and c will be numbers when we're solving the problem. So we're going to look for the values of x that cause y to be 0. Now, there are a lot of different ways that you're going to learn how to do this. Kind of like, it reminds me a lot of when we did systems of equations. When we started solving systems of equations, the first thing that we do is we learn how to do them graphically, and we're going to do that with this as well. The first thing that we'll do is solve them graphically. You'll kind of discover that solving them graphically, just like it was with systems, it's kind of a pain, and it's actually a pain for kind of the same reason as it was when we solved systems, because when we solved systems of equations and you found where the two lines intersected, it only worked out graphically by hand if they actually intersected at integers. If they were at decimals or fractions, then you kind of were stuck not understanding what the answer was. And it's the same case here. If your answers aren't integers, then just doing it graphically by hand is not a very effective method. Now you can solve these graphically using a graphing calculator and actually find the actual solutions if they're decimals or fractions, but we're not going to make the assumption that everybody has one of those. It's something that if you do have one of those, the book kind of shows you how you can use that and you can work with that as well. Just make sure you're able to do what I'm asking you to do without the graphing calculator. So we're trying to solve quadratic equations. We're trying to find the solutions. Another word for the solutions of a quadratic equation are the zeros. And that's pretty easy to remember because you're looking for the values of x that make y 0. So the solutions or the zeros. It's good to just sketch a graph here and take a look at what this actually looks like. So if we draw a coordinate plane, and I'm not even going to mark this with numbers, I'm just going to give you a quick little sketch. Let's say we have a parabola that looks like this. Well, try to see if you can point out where the solutions or the zeros of this graph are. Hopefully, you pointed out this point and this point. These are the 2 points on the graph where we have an x value that has a y value equal to 0. Now, since I didn't put any numbers on there, we have no idea what the actual answer is, but this is just an example. So one of your zeros would be the x value of this point, the other 0 would be the x value of that point. Now, it does not always turn out that you have two solutions to a quadratic equation. That is the most common thing that will happen, but it's not always what will happen. Let's look at a couple more examples. So I'm going to, again, just draw you a little sketch, and I want you to kind of point out to yourself where you think the zeros are. I'm not even going to bother putting numbers on it. So let's say this time the parabola is upside down. Where do you think the zeros or the solutions are now? Hopefully you pointed out this point and this point. Again, those are the points where y equals 0, otherwise known as the x-intercept. So you could use the word x-intercept here as well. And once again, notice there were two solutions. There will not always be two solutions. Before I show you, what do you think a graph would look like where there's only one solution? Before I show you here, try to sketch one real quick. If you need to pause me to do it, try to sketch one real quick. Sketch a parabola that only intersects the x-axis in one place. I'm going to go ahead and do it now, so if you haven't already, pause me and make sure you can. Basically, a parabola that has one solution is one where the vertex is right there on the x-axis, kind of like that. It just bounces off. So there only ends up being one intersection point. It could also go the other way, like it could be like this. So again, this one also only has one intersection point there. There's only one value of x where y would equal 0. All right, why don't you think to yourself what a graph would look like if there was no solution? Because no solution is also a possibility here. And why don't you try to sketch that real quick? All right, for there to be no solution, basically the parabola would have to open up and be above the x-axis, so something like this. So notice it will never get down to the x-axis, so y is never going to be 0. Or it could be flipped around the other way and it could be opening downwards, but it could be below the x-axis, so something like this. There's no point where that's going to intersect the axis. There's no point where y will ever be 0 on that function. All right, so those are the three possibilities. We could either have one solution, two solutions, or no solution. Most often you'll have two solutions, but the other two cases do come up quite a bit. They're not just corner cases that barely ever show up. They do show up. So it's important to be aware that just because you're getting no solution or one solution, that doesn't mean you did the problem wrong. All right, well, now we can find the exact solutions by graphing as long as the exact solutions are actually like nice numbers that we can figure out pretty easily. Otherwise, graphing is really not the best way of doing it, and we're going to learn some algebraic ways that are significantly easier. The book gives you some problems that are even easier than making you graph it. They simply give you problems where they give you the table of values, and they say, all right, here's a table of values for x and y. And I'm going to make up numbers real quick. These numbers might not even make sense. Let's just say when like x is -5, let's say y was, I don't know, 2. When x is -4, let's say y was 0. When x is -3, let's say y was -4. Let's say when x was -2, let's say y was 0, and when x was -1, let's say y is 2. So again, these numbers might not actually make sense or actually make a graph that would look right. Ignore that. But just look at this table of values, and if they gave you this table of values as the problem, and they said, what are the solutions or the zeros to this function, try to determine what they are right now. So remember what we're looking for. We're looking for the values of x where y equals 0. We know there might be none of them, there might be one of them, or there might be two. And in this case, hopefully you saw that there were two. This one right here, -4, y is 0, so when x is -4, that is one of the solutions. And here is the other one, when x is -2. So you could write x equals -4 is one solution, x equals -2 is the other solution. So when you're given the table, it's quite easy. Also, if you have a graphing calculator, an easy way, like if you had to solve using graphing, but you're allowed to use a graphing calculator, you can graph it using the graphing calculator, and then you can press the button where it just brings up the table, and you can just look through the table to find the points where y equals 0. But again, it's only easy to find if you know what intervals to go through on the table, whether you're going 1, 2, 3, 4, 5 on the x, or whether you're going like 0, 1/2, 1, 1.5, 2, something like that. If it's too much trickier than that, then you won't be able to find it on the table very easily. Let's do a couple where we actually solve using graphing. Now, as you may guess, there's nothing new here. We've already worked with graphing quadratics. So, if you already understand how to graph quadratic equations, the only thing that you needed to add to that knowledge is the idea of what the zeros actually are. And hopefully now you have that down. So really, there shouldn't be anything new here from this point on. Once you get the fact that the zeros, the solutions, are where this graph intersects the x-axis, that's the only thing that's new. The rest of this is really just going to be practicing graphing a little bit. So let's try one together here. Let's say, what if we're graphing, and it doesn't really matter if we say y equals or if we say f of x equals, let's just say f of x equals. And let's do one, what do I want to do? I've got 3 in front of me. I'm just deciding which one I want to use. This is probably the best one. Let's do x squared minus 14x plus 48. Remember, when you're actually solving this quadratic equation, you're trying to find the values of x when y equals 0. So you're solving the equation x squared minus 14x plus 48 equals 0. If you are comfortable and confident with going ahead and graphing this, go ahead and do it now. If graphing in standard form is still giving you trouble, then maybe hang on with me and go through this one with me, and maybe the second one you can do on your own. All right, let's take a look here. So we need to find the vertex, we need to find the axis of symmetry, and then we're going to need to find a few more points. In this case, it's possible that we'll need to find more points than we usually graph, because normally we only graph like 5 points, but if you only graph 5 points and you don't get to the solutions, and you can tell that you need to go further out to get them, you might need to graph more, but we'll figure it out. So remember, for the axis of symmetry and the vertex, before we even draw the coordinate plane, we kind of want to know where on the coordinate plane we are. So let's figure that out first. Remember, to find that axis of symmetry, we say x equals negative b over 2a. So in this case, we're going to say x equals negative 14, so otherwise known as positive 14, over 2a, which is just 2 times 1. So 14 over 2 is just 7. So we know the vertical line at x equals 7 is our axis of symmetry, and that's also where we're going to have our vertex. And actually, I shouldn't put the x-axis in yet, because we don't really know how far up or down that is. So let's go ahead and find where the vertex actually is. So let's plug in that x value. So we're basically saying, all right, let's find what f of 7 is. So let's find the value of y when x does equal 7. So we're doing 7 squared minus 14 times 7 plus 48. These numbers are big enough that I should at least type in the calculator to not make a mistake here. So when we're finding f of 7, 7 squared is 49. Then we're doing 14 times 7, which is 98. Plus 48. So 49 minus 98 plus 48 gives us negative 1. So f of 7 equals negative 1. So we know that the vertex is at the point 7, negative 1. So that helps us when we're graphing this. We also know, since this here is positive, it's a 1 in front of the x squared, we know it opens up. Therefore, that point 7, negative 1 is going to be the minimum. So when I'm drawing this graph, I'm keeping in mind that that point is going to be the lowest point. So I'm just giving myself a whole lot of space to the right on the coordinate plane and a whole lot of space up on the coordinate plane. 1, 2, 3, 4, 5, 6, 7. So this is where we know here And we know that vertex is here at 7, -1 right here. We also know this is going to go up. So one thing we can kind of tell is we're going to find our solutions pretty quickly here. We already know there's going to be 2 solutions because we don't know the exact shape that this is going to take, but we know it's going to go up like this and it's going to go up like this. So there are going to be 2 places where this intersects the x-axis. All right, well, let's find exactly what they are. We've got to plug in some new points. I'm going to erase this work. You shouldn't be erasing any work on yours. So let's get the point 1 to the right and left of this. If I had to guess, I'd say this is probably going to be our answers if we just go 1 to the right and left, just because we're already so close to the x-axis. So we can plug in 6 or we can plug in 8. We might as well plug in the smaller number, but it's going to give us the same answer. So let's find what f of 6 is. We're doing 6 squared minus 14 times 6 plus 48. And my guess is here that this is going to come out as 0. But let's see. 36, and then we're doing 14 times 6, which is 84, so minus 84, and then plus 48. Let's see if, in fact, this actually comes out as 0. 36 minus 84 plus 48, and it does. Comes out as 0. So we know that this is a point, and we know that this is a point. Now, technically, if all we were trying to do was just get the answer, we could stop right here because we have it. If we're actually trying to graph it, like if I asked you on a quiz to graph it, I do want at least 2 more points so your graph, because right now you have no idea, you only have these 3 points to kind of guess at how this looks, but you don't really know how wide or how narrow it's going to be from there. So let's get at least 1 more point to the left and right, but we already know our answers here in terms of our solutions. Our solutions or our zeros are going to be x equals 6, and x equals 8. Those are the 2 values of x that make y equal to 0. So we've already finished, but let's just graph a few more points so this looks a little better. Let's try plugging in 5 or 9. Wait, no, 5 or... Oh yeah, because that's at 7, so 5 or 9. Might as well do the smaller number because it's going to be the same answer. So let's find what f of 5 is. I'm definitely not going to bother using the y-intercept here, because if you notice the y-intercept is 48, and I'm not going to graph 48. And that's not surprising. Like, we know that this is going up like this, so that's going to be way up there somewhere, but that's going to be way off the graph. All right, so let's find what f of... Wait, what did I just start to write? I just started to write 8, or was that from before? I want to find 5. I want to find f of 5. So we're going to do 5 squared minus 14 times 5 plus 48. Oh, this is starting to write kind of slow. I should restart this computer. Let it after this video. All right, 25. 14 times 5 is 70, so minus 70 plus 48. All right, we definitely expect this. This number better be greater than 0 because this is opening up. So let's do 25 minus 70 and then plus 48, and that gives us 3. So that means we're going to go up 1, 2, 3, and then we'll reflect that over to here. And if we wanted to, we could graph 2 more, but really the whole point was to find the solution here. This is sufficient. If you do 5 points, you get a pretty good idea of what the parabola looks like. 7 is probably like the perfect number, but 5 is certainly sufficient. That's it. So if you had the graphing down, if you already knew how to graph these, really the only new thing was just identifying that this and this are the solutions. And remember, the solutions are the x values. So it's x equals, what, 8, and x equals 6. Those are your zeros, those are your solutions. And if you wanted to, like if you weren't confident if this was on the map test, if this was on an exam, something like that, and you wanted to make sure you got the right answers, you could plug those numbers 6 and 8 into the equation to make sure they actually worked. You could do 6 squared minus 14 times 6 plus 48, you would get 0. You could do 8 squared minus 14 times 8 plus 48, you would also get 0. But it's a good idea if you aren't completely confident in your solution. That's a way to check your work and make sure it actually works. Just like any equation. Once you get the solution, go back, plug it into the equation, and make sure it actually works. All right, I think that was pretty good. Why don't we just do one more here as practice? And if you didn't try this on your own, maybe this one you can try on your own. Maybe we'll mix this one up a little bit by flipping it upside down. Why don't we do that? Let's flip it upside down. Oh, this is not erasing. Okay. This computer definitely needs a break. All right, let's just move to a new part. Okay. All right, try the following. Try f of x equals negative x squared minus 7x minus 6. And just glancing at this, I can tell you are, this isn't a great one. This is okay, so don't get to, I made sure to pick ones where the solutions are actually going to be integers or whole numbers. Don't get too thrown off here by the fact that the vertex is going to kind of be a nasty number here. The vertex is not going to be a nice looking number, but you can still graph that. The other numbers that I think you'll come up with here will work out well. This will work out fine. It's just your vertex isn't going to come out that nice. So just be aware of that. All right, go ahead and give this a try. Pause me and then come on back. All right, let's take a look at this. I could already tell that the vertex was going to be bad because we're going to be dividing 7 by 2 here, because when we find our axis of symmetry, when we do the x equals negative b over 2a, we're actually going to do negative 7, so 7, divided by 2 times negative 1. So otherwise known as 7 divided by negative 2, which is negative 3.5. I imagine one mistake that some people might have made here was having positive 3.5 instead of negative. You have to remember, if you're taking negative b and b is already negative, then you make it positive. Also, you have to remember, if a, there might not be like a number here other than that negative sign, but you've got to remember that means it's a negative 1, so you've got to account for that. All right, so we've got the x coordinate of our vertex. Now we're going to have to find the y coordinate, and I imagine this isn't going to come out all that nice just because we already have a decimal. So we're trying to find what f of negative 3.5 is. So we're going to say negative 3.5 squared minus 7 times 3.5. Let's see how bad this is, minus 6. But I think this is the only bad one that we'll actually have here. So 3.5 squared is 12.25, so negative 12.25. Remember, with your order of operations there, you're squaring the 3.5 and then you're making it negative. I could see that as another place where people might say, okay, I'm going to square a negative and get a positive, so be careful with that. All right, and then we're doing 7 times 3.5 here, so we have minus 24.5. Something went wrong. What just went wrong here? Oh, yeah, I was going to say, I didn't think that was supposed to be negative. Luckily, I caught that mistake as I was making it. So I forgot to plug in. So the number we were plugging in here was negative 3.5. I wrote it as positive 3.5 in both places. Now, when we did it here, it made no difference because we squared it. So it did become positive, but then it became negative again. Let me just rewrite this. Let me rewrite this. I don't want to throw anybody off. So this is negative x squared. So x is negative 3.5. That's what we're squaring. And then we're subtracting 7 times negative 3.5. Okay. That first number is still right. It's negative 12.25 because you squared a negative, which became positive, but then you multiplied it by a negative again. But for the second one, this is actually a positive because I was confused why it was coming out as negative when I didn't think it was going to. All right, and then we subtract 6. Okay, this is going to be right. So let's see what that gives us. Going to give us 6.25. So that's not awful. We can graph that. We'll just estimate it. So we know this one opens down. We also know that this point is the highest point. So we'll kind of arrange our graph here so that we have space below this. So let's see. I'll kind of set it up like this. Kind of the opposite of the last one, if I recall, sort of. Kind of like this. Give ourselves enough room. You know, our axis of symmetry here is at negative 1, 2, 3.5. So right in between negative 3 and negative 4. I don't know if we've done one of these where our axis of symmetry like that is at a decimal. I could look back in the book and see, probably not even worth looking back to see if we did any of those. I don't know if I don't think I went over one of these in the video, but well, that's okay, no big deal. All right. Okay, so there's our axis of symmetry, and let's put down the vertex. So the vertex is at negative 3.5, 6.25. So we'll just go up 1, 2, 3, 4, 5, 6, and then a little above it. That's enough. That's sufficient. Doesn't have to be exactly in the right place. The point that really matters here in terms of being in the right place are the two solutions. And we do know there's going to be two solutions already because we know this is opening up something like this. So we know there will be two. If our vertex was right there on the x-axis, we would know that there was one. If this was opening upwards and our vertex was here, then we would already know that there were no solutions. All right, let's put some of these marks in, and then let's try to find what these solutions are. So we know the value of y when x is negative 3.5. What I would do is I would immediately go to the right and to the left of that, but normally we go to the right and left 1 unit away. But since this is a decimal, let's just go to the right 1/2 and let's go to the left 1/2. So we know what negative 3.5 is, but let's find out what f of negative 3 is and what f of negative 4 is, because we know those are going to be the same. So we could either plug in negative 3 or we could plug in negative 4. Again, it doesn't really matter which one. I usually just take whatever number has the smaller absolute value just to keep the numbers, I guess. It always feels to me like that's a little bit easier if the numbers look a little smaller, even though technically it's bigger, but whatever. All right, so we're going to find f of negative 3. So we're going to do negative 3 squared minus 7 times negative 3 minus 6. It's just there's so many negatives in these problems that it's just very easy to make a mistake. Luckily, if you make a mistake on these, often the graph ends up just looking wrong. So you will often catch your mistake because you really do, we know what we're kind of expecting here. Like we're expecting a parabola opening downward. And if you make a major mistake with a negative sign, it often will get jumbled. And that's another advantage of graphing more points, because if you only graph 3 points and you make a mistake with these two, you might not catch that you made a mistake. But if you graph 5 or 7 points and some of them were wrong, then the whole graph overall won't really look right. All right, so let's give this a try here. So negative 3 squared is 9, but then we make it negative, so that's negative 9. Then we do a negative times a negative, which is a positive. It's positive 21, and then we're going to subtract 6. So we're basically doing 21 minus 9, and then we're subtracting 6 again, and we're getting 6. And let's see what these points look like. So that means instead of being at 6.5 like this, or 6.25, the next 2 points just drop down to here and to here at 6. So they didn't move too far. So we're definitely going to need to graph a few more if we want to find our solutions or zeros. It is kind of nice to graph a couple points that are really close to the vertex like that, because when your very first points that you graph outside the vertex are far away, then often your parabola kind of starts to look more like a V. But when you really get some of those early points, it shows you how they curve out a little bit better. All right, so let's go one more unit to the right and to the left. So what we found here was -3 and -4. So let's go out to -2 and -5 this time. So I'll use -2 in the equation. So let's find f of -2. So again, it's -2 squared minus 7 times -2 minus 6. So -2 squared is 4, but then we make it negative. Plus 14 minus 6. Let's see if we come out with 0. I don't expect to. I bet it's going to be 1 or 2 more out, but let's see. So -4 and 14 give us 10, and 10 minus 6 is 4. So we actually got pretty close. Or not, no, we didn't really get close. We got closer. We expected this. We expected it to be lower than it was. So now it's at 1, 2, 3, 4. We have this point, and it's at 1, 2, 3, 4. We have this point. If I had to guess, I bet our next ones are going to be the solutions, because if you see how far these are apart, the next ones are going to be even further apart. So I don't think we could fit 2 more points in. So I bet our next ones are going to be it. Let's see if that's actually the case. So now we're going to plug in -1. And actually, we already know, without even graphing these, that if our answer is going to be an integer, it has to be the next one, because the one after that would include the y-intercept. And you already know what the y-intercept is. If you made x 0, the y-intercept is -6. So we already know that the next point here is 1, 2, 3, 4, 5, 6. We know this is going to be a point. And if you reflect that over 1, 2, 3.5, 1, 2, we know that it's going to be here. So unless our answer is going to be a decimal or a fraction, it's going to be at that next point. But let's make sure algebraically that it actually works. So we're going to test -1, which would also be the same as -2, -3, -4, as -6. So we're guessing here that it's going to be -1 and -6. Let's see if that's actually the case, and it better be, otherwise it's a decimal that we can't find. So we're going to say, what's f of -1? -1 squared minus 7 times -1 minus 6. -1 squared is 1, but then we make it negative. Then we're adding 1 to it. Wait a second. I wrote something funny. Let's go back. I never wrote the 7 in here. Okay, so this was supposed to be minus 7 times -1. There we go. Okay, so again, we're starting with a -1. Then you're adding 7, then you're subtracting 6. And as expected, that comes out as 0. So that gives us this point right here, and that gives us this point right here, which are our 2 solutions. So our solutions are x equals -1 and x equals -6. And to kind of finish off our graph here, and you kind of see those 2 points, this one and this one, really do help you see that it's not a V and that it's a U. Those 2 points kind of force you. Like if you didn't have those 2 points, a lot of people start drawing it like that, like straight to that next point rather than curving it out as much as it should, which is why those points kind of make your graph end up looking a little bit better than when you don't have them. All right, I think that's enough. I think that's enough to get you started. I mean, really, this is one of those lessons where if you understood what we did when we were graphing these, there's really not much new to this. And if you were still having trouble with it, this is kind of just another chance for you to get caught up on that older concept. So you've got some homework problems to do, and then we will be moving on from here, and you're going to learn a few other ways to solve these algebraically. So I will be around if you have any questions. You can get me the way you normally get me. I'll be there for office hours, or shoot me an email, or send me a question on through the homework document. Have a great day.